Hello everyone, welcome back to Shocking Maths and Science. In today's video, we'll be doing an introduction to chemical equilibrium. So in this series, I'm going to break it down step by step and try to make it more simple as possible as I can from zero to mastery. So by the end, you'll understand one of the most important concepts in chemistry. Let's start. What actually is equilibrium, right? What actually is equilibrium? So think of your bank account. Imagine money is coming in, right? You deposit 100 rand. Imagine you deposit what? 100 rand, right? So now at that same time, after depositing that 100 rand, you eat that 100 rand, right? You spend that 100 rand. Now what happened now? Your balance stays the same, right? Your balance stays the same. That doesn't mean that nothing happened. Nah, it means that something is happening, but both processes are equal, right? Both processes, they are happening at the same time, right? That's what we call equilibrium, right? We talk about something that is balanced. So in a context of chemical equilibrium, reactants turn into products, right? Reactants turn into products, but products can also turn back into reactants. So we then say at equilibrium, right? At equilibrium, the forward reaction and the backward reaction, they happen at the same rate, right? We then say at equilibrium, the forward reaction and the backward reaction happen at the same rate, right? So now let's dive into the conditions for equilibrium, right? Let's dive into the conditions for equilibrium. I really hope it makes sense that what is chemical equilibrium, what is equilibrium. So let's dive into the conditions for equilibrium. Sorry about that. So now, one of the conditions for equilibrium is that we say for equilibrium to be reached, a system must be closed, right? We must have what? A closed system, right? We must have what? A closed system. For instance, let's say you are boiling water inside the pot. Let's say you are boiling water inside the pot. Now, as you boil that water, as that steam rises, what happens to the steam as it reaches the pot? That steam turns back into what? Into liquid form, right? That steam turns back into what? Into liquid form. So that's what we talked about, is that the reactants can turn back into products. So that is one of the conditions for equilibrium to be reached, right? I really hope that makes sense, grade 12. That for equilibrium to be reached, a system must be closed, right? Because if you are having an open system, that reaction will what? Will reach completion. I really hope that makes sense. So another condition is that the reaction must be reversible, right? The reaction must be reversible. The reaction must be reversible. So we must have what? A reversible reaction. For instance, let's say we have lead nitrate, NO3, 2 plus potassium iodide for reversible reaction. So this double arrow implies what? Reversible, right? This double arrow implies what? Reversible. It implies that that reaction, it is reversible. Whenever you see a double arrow, implies that that reaction is reversible. So to form what? Lead iodide and what? Potassium nitrate. Potassium nitrate. So is it balanced? Okay, now we are having 2 in there. So we'll have to put a 2 here and we'll have to put a 2 here. So now it's balanced. So now, as you see this reaction, it has a double arrow. This double arrow, it implies that what? That reaction, it is reversible, which means that reaction can never reach completion, but rather it can reach equilibrium. So this is the second condition for what? For equilibrium to be reached. I really hope that makes sense. So into the next video, we will dive into what is dynamic equilibrium. So for now, please hit the like button, subscribe, so that you'll be notified whenever I upload. Thank you.